Alright, today we're looking at another Leetcode problem. This is problem number 236, and in this problem we have to find the lowest common ancestor of a binary tree. Note, this is not a binary search tree, so we cannot find elements in logarithmic time complexity. We will have to scan through the whole tree. Alright, so what is a lowest common ancestor? So the definition says that if you have two nodes, let's call them with the same notation P and Q, and if there is a parent and let's say maybe multiple parents, then we are looking for the lowest parent to these nodes. Now, another point that I've said here is that a node itself could be the lowest common ancestor. So the node itself can be returned as the lowest common ancestor. Now, this problem can be solved in two ways. Let me tell you the first approach. The first approach is that you traverse through the whole tree and you try to identify the path to these target nodes, right? So if you have to take the path to P, that would be from root node you go to 5. Okay, to Q, that would be from root node you go to 1. Okay, and then if you look at prefix, assuming there were more parents, then you take the lowest common value and that's what you return. Okay, I'm going to use a different approach. I'm not going to use this approach because this requires you to traverse through the whole tree twice to find this path. So the approach that I'm going to take is the recursion approach. To understand the recursion approach, we have to understand two things. When from a particular node we are going to its subtree, let's say the left subtree and the right subtree, what is that call looking like? What information are we passing in that call? And once this subtree is processed, what are we returning from the call, right? And identifying just these details will help you to define what the recursion will look like. So let's take a crack at this. Now, what we are saying is that first let's go back to the definition. So what the definition says is if I have a node X and if this is equal to either one of the targets, okay, then this node is a potential LCA. I'm not saying this is the LCA because there could be another node which might be in another subtree, but there is a potential that this could be a LCA. Now, when will this be a subtree? Sorry, when will this be an LCA? This will be LCA when my Q is in one of its subtree. Then this is the lowest common ancestor. And when will this not be LCA? When there is another, let's say another subtree where my Q exists, then the immediate parent of this one will be the LCA. So this is the rule that we need to codify. Another thing before I erase this is that once we have identified the LCA, let's say this is the LCA. Okay, once we have identified, even if there's a parent, we should not consider this parent as the LCA. So we should propagate the result back. So what we are saying is that we are making a call. So we are making a recursion call to every node's left, and we are making another recursion call to every node's right child, and at every step we are getting some result. So this is left result and this will be equal to the right result. Okay, so let me just clean it up and we can talk about the recursion now. So what I'm saying is that I will have left result and then right result because I am doing recursion and this is a binary tree, so I have only two calls, left and right call, and so this is a recursion. This goes to node dot left, and this is another recursion. This now. Alright, so so we were talking about the recursion, and now let us understand what are the values that I can get from this recursion, right? So you have recursion where you get a node, okay, and there has to be something that you return, okay, and that is the return that you're going to receive here and here. And now here you're going to make some decision, and based on the decision you're going to return another thing, another value from this. So let's start filling this part up, okay. So what are the things that we can say? If we have reached the end, okay, if we have reached the end where there is none or no node, let's say if not node, I will return none because it doesn't mean anything. I have not found any LCA. Okay. Now, when have I found LCA? So let's see. I'm going to tell you something. So if node dot value is equal to p dot value, or if node dot value is equal to q dot value, I'm going to say that I have found a potential LCA. Now, what does this mean? Let's look at it. So, if I am here, okay, I am seeing that I have found one of the target nodes, which is P, and so I'm not going to process the left subtree or the right subtree. But why? We have 4 here, which is a potential, another target. Doesn't matter, because what the problem says is that a node can be a LCA, okay. And if I have found 5 here, what I'm saying is that I am not looking to find all the values, because so there are two things. Let me just write it down to make it simple to understand as to why we are excluding processing the subtrees, right? First point that the problem says is that P and Q always exist, okay, which means it's either 4 either exists here or 4 exists in another subtree, doesn't matter, okay. If I don't find 4 here, I am not going to get a node from this side, and if I am not getting a node from this side, that means I would have found the node on this side, which means as a subtree of 5. That's all I'm looking at. I'm looking at signal of which side am I finding these target nodes, okay. So I will say that if I find this, then I will return as it is. Now let's do the decisioning, okay, where in first case I find 4 here, so I am let's take one example, right? The first one. In the first example, I am going to return 5 because yes, I found 5, and when I find 1, yes, I'm going to return 1. Okay. In the second case, what's going to happen? I'm going to return 5 because I have found 5 and I'm not processing anything more, and there's no 4 on this side, so I'm going to return none. So this node is going to get 5 and none. So now let's handle that condition. So now what I'm saying is, if left result, to simplify, I'm just going to call it if LR is not none and RR right result is not none. What does that mean? It means I found the target node on the left hand side and I found the target node on the right hand side, and this is the first time I'm finding it in the split. That means the current node at which the split is happening has to be the LCA, okay. So that has to be the LCA, so I will return the node, okay. Now the second case is I found the left side, left result has returned me a node, but the right side has returned a null. That means this has to be the LCA. Same way, um, if I found 1 and 5 was underneath this, then I would have just returned 1, and from here I would have gotten a z or none, and so then this would have been an LCA. Okay, so let's code that up. L if RL is not none, then return RL. Sorry, if left result, then return left result. Is not none, then return left result. Else if right result is not none, return right result. And if I have not found anything in the left and right of my current subtrees that I'm executing, then I will just return none. This is the recursion, this is all that is there to it, and this will return you the result. That was it for this problem. Hope you liked it. Thank you.